Good afternoon. Good afternoon, one and all. Today the class is lecture 19 of from Unit 2 of Fluid Mechanics. In this class, today we will discuss about some of the problems of one-dimensional, two-dimensional. Okay, so we'll discuss the problems, one-dimensional problems, two-dimensional problems, and three-dimensional problems of classification of flows. So in the last class, we have discussed about the classification of flows and problems. So after 6 types of classification, right? So based upon the 6 types of classification, we will discuss some of the problems related to the flows, right? Okay. So the classification of flows is everything is completed. Classification of flows is everything completed. So now we are doing the problems at 1 dimension, 2 dimension, and 3 dimension analysis, right? Okay. So in the last class we have discussed about some of the formulas also. What is the Reynolds number, right? So Reynolds number RE is equals to pi rho into V into D by mu, that is VD. So where V is equals to velocity of flow, V is equals to diameter, and K is equals to kinematic viscosity, right? So in the continuity equation also we have derived the equation. What is the equation? A1 rho 1 A1 V1 is equals to rho 2 A2 V2. When these are incompressible fluids, we are calling this continuity equation as A1 V1 is equals to A2 V2, right? Next. In the continuity equation in three-dimensional analysis also we have derived by taking x-axis, y-axis, and z-axis. So by making use of the velocities u, v, w for x-axis, y-axis, and z-axis, we have derived the formula for the three-dimensional flows. Which one is this one, right? So here we are having a cuboid, where here from this direction first we are calculating, right? From y direction we are calculating, right? From the z direction we are calculating, right? Like this we are doing a process like this. Okay, next. So if you see the three-dimensional view of a solid part, the fluid element in the fluid, we are having the certain length dx, dy, and dz, which are the directions with respect to the x-axis, y-axis, and z-axis, right? So based on those things, we have calculated the x-axis formula, y-axis formula, and z-axis formula. Now, with those things, we will slowly start the problems in the one-dimensional, two-dimensional, and three-dimensional. Now, if you see the problems, when 2,500 liters of water flows per minute, when 2,500 liters of water is flowing per minute through 0.3 meters diameter pipe, which later reduces to 0.15 diameter, means slowly it is decreasing. Slowly the dimension is, the diameter of the pipe is reducing. So initially here we are having 0.3, here we are having 0.15 diameter. Calculate the velocities of flow in the two pipes. So the question here is we have to calculate the velocities of the two pipes. Okay, now if you see what is the discharge here, the discharge 2,500 liters of water. The discharge is 2,500 liters per minute, that is equals to 2,500 into 10 to the power of 3 by minute 60, that is equal to 0.4042 meter cube per second. Now what is it given here? The diameter of pipe D1 is equals to 0.3 meters. Diameter of reducing pipe is equals to 0.15 diameter. Therefore, which diameter though? So it is a circular pipe, then calculate the area A1 pi by 4 d1 square, that is equals to this one 0.0707. Next, for A2 pi by 4 d2 square, that is equals to 0.0177. Now velocity at the inlet. So velocity, we are calculating the velocity at inlet, velocity at outlet, right? Velocity at inlet Vi or V1, velocity at outlet V0 or V2. We are doing here V1 is equals to Q by A. We know the velocity Q by A. That is equals to Q is equals to 0.41, 0.402. Students, join the class. It has already started. Yes. Okay. See, the simple problems like this, one-dimensional problems or simple problems, what it is, the things, major things, we have to see the the discharge. We have to see the discharge. We have to see the discharge Q, and we have to see the diameter. The diameter D is given. The diameter, lower end diameter D is also given. Now, after getting the given in the given diameter in the given data, calculate A1. Next, for D2, calculate D2. Then we are getting area of diameter, starting area of diameter, ending. Now, what is the question given? The velocity of inlet and the velocity of outlet. In the last class lo meer em chesaru, we are finding the area or discharge. So akkada velocity icharu. Now here we have to find the velocity. Therefore V1 is equals to Q by A1, V2 is equals to Q by A2. That is equals to 0.594 at the initial thing, 2.37. Why 2.37 high here? Why? Because the diameter is here less diameter when compared to the other end of the pipe. That's why the rushing, the velocity will be more when compared to the velocity at the one side, right? So like this, you have to do the simple problems based upon the velocities or discharges. So with this continuity equation and the three-dimensional equation, we'll solve some of the bigger problems also, right? Now see here, the next problem, a 25 centimeters diameter pipe carries oil. So here the medium is oil. The specific gravity is 0.9 at a velocity of 3 meters per second. Another section, the diameter is 20 centimeters. So manaki ela undi ippudu pipe. So in some cases the figures will not be shown. You have to draw the figure by assuming. So what is the given data? A 25 centimeter diameter pipe is reduced to 20 centimeter. Ante pipe ela undi, ila undi pipe. Pipe is like this. So at this point the pipe is 25. At this point the pipe is 20. Find the velocity at this section and also mass rate of flow of the oil. Now what is the medium flowing inside this one? Inside this one, oil is flowing with a specific gravity of 0.9. So velocity is given for initial velocity is 3 meters. Initial velocity is 3 meters. So what to find? The rate of flow? Rate of flow at the section 2. Now what is the given data? At section 1 దగ్గర data రాసుకోండి. At section 1, D1 is equals to 0.25 meter. A1 is equals to pi D1 square by 4. That is equals to 0.049. Therefore V1 is given in the question. Now at section 2, D2, what is D2? 0.2 meter. A2 is, you have to calculate 0.03. We have to find V2. ఇక్కడ మనకి V2 కనుక్కోవాలి. Now by using the continuity equation, how to find V2? So ఈ formula you have to keep in mind. ఈ formula మీకు గుర్తుకు రావాలి. Using the continuity equation, A1 is equals to A2, A1 is equals to A2. This A1 is equals to A2 formula you have to keep in mind. Why? Because we know A1, V1 and A2. V2 ఒకటి తెలియదు. So we have to take this formula for easy understanding. Therefore V2 is equals to A1 V1 by A2. Substituting in those, we are getting 4.68. So in correct or wrong, ela telustundi. So if you see the velocity of V1 is 3, the V2 is 4. So V1 kante V2 velocity ఎక్కువ. Why? Because the taper is in this direction. ఇలా ఉంది taper. తగ్గిపోతా ఉంది diameter దగ్గర. Right? So అది ఈ పొజిషన్ లో ఉంటే ఆటోమేటిక్ గా this will be bigger than this one. Hope understood the problem. Right, we'll go to that. What is the next thing you have to find? The mass rate. So with this, the mass rate, Q is equals to rho into A into, here what you are using? Here we are using the oil. So for that reason, the mass rate M is equals to mass density into Q. That is equals to rho into Q is equals to A1 V1. What is the specific gravity of oil? Specific gravity of oil is equals to 0.9 into 1000. That is equals to 900 kg per meter cube. So here the specific weight is 0.9. Here the specific weight is, for the specific weight, here there is 0.9 at the velocity of 3 meters per second. Now rho is equals to specific weight into density of mass, that is equal to 900. Now what is the mass rate of flow of oil? M is equals to, right? M is equals to rho into A into 1. Mass flow rate, M is equals to rho into A into V1. Now we know rho value 900, we know A1 value, we know V1 value. Totally the value is 132 kg per centimeter for the mass rate of flow of the oil. And what is the last point it is asking? It is asking what is the rate of flow of oil. So this one is the rate of flow of oil. Okay, understood? Now we'll see somewhat bigger problem. Here. Now consider a 30 centimeter diameter pipe, conveying the water branches into two pipe systems. So 30 centimeter dive, 30 centimeter main pipe, due to some more applications we are using, because of some more things, this pipe is split into two pipes. This pipe is split into two pipes. What are those? Diameter is 20 mm. The diameter is 20 mm. The diameter is 15 mm. Okay. If the average velocity in the 30 centimeters diameter pipe is 2.5 meters, so here the velocity is 2.5 meters, then find the discharge in this pipe. Also determine the velocity in 15 centimeter pipe. Also determine the velocity in 15 centimeter pipe. If the average velocity in 20 centimeter diameter pipe is 2 meters per second. So it's also given the hint, if the average velocity in a 220 centimeter diameter pipe is 2 meters per second. So what is the question saying here? So in order to overgive the velocity of D3, that is 15 centimeters, and also to find the area, to find the average velocity of the pipe. Now with this question, just we can draw the pipe. First pipe is 30 centimeters pipe. D1 is equal to 30 centimeters. It is split into two ways. One D2 20 centimeters, D1 is 15 centimeters. So it is mainstream anukunte 2 and 3 are substreams. Now if you see V2 D2 and V3 D3 substreams, so according to the question only we have given the data. V2 is equals to 20 meters per second, DT is equals to 20 centimeter, whereas V3 is equals to question mark, V3 is equals to 15 centimeter. Okay na? Now what is the given data? The centimeters. If the average velocity in 20 centimeter diameter pipe is 2 meter, if the average velocity in the 20 centimeter pipe is 2 meter, Now find the areas for all the pipes. Now D1 is equals to 30. Therefore, area is equals to 0.070. Next, V1 in that enter 2.5 meters per second. Next, D2 is equals to 0.2 meter. Therefore, substituting for getting area A2 is equals to pi d square by 4. We are getting the value. Right? Next, third one. So what is the velocity for the second one? 2 meters per second. Now D3, 15 centimeters. A3 is equals to pi d cube by to the power of 2. That is equals to 0.01. Right? Simply we have done the area calculation. Areas manamu kanukunnamu. Now after later that we have to find the discharge. We have to find the discharge. Discharge is equals to denikaithe already unnayo. Discharge Q is equals to A1 is equals to A2. A1 is equals to A2. That is equals to A1 is equals to 1C. Okay. That implies A1 V1 substitute cheyandi. We are getting the value 0.1767. Next, velocity of 15 centimeter pipe. Kanukkovali velocity. Now let Q1, Q2, Q3 are the distances at the point 1, 2, 3 respectively. Then according to the continuity equation, Q1 is equals to Q12 plus Q23. Adi we have derived in the continuity equation. This is a mandatory thing. What is the according to continuity equation? Q1 is equals to Q2 plus Q3. Therefore, Q1 is equals to 0.1767. Then Q2 is equals to A2V2. Q2 is equal to A2V2. That is equals to A2 is given and velocity 2 also is given 0.06. Now, finding Q3 is very easy, right? Q3 is equals to Q minus that is equals to 0.06. Q3 is equals to 0.0628 minus 0.1767. That is equals to 0.11. 0.11. That is the answer for Q3. Then what is the velocity? The velocity is the velocity is equals to 0.1139.07. This is the answer you have to find at last. Which is a point you have to find at the last. Like this you have to do whenever the V1, V2 is given, V3 is not given, or whenever A1, A2 is given, A3 is not given. How to rid out of the vehicle, get rid of the vehicle? Do your fix, right? So like this, whatever the velocity, it may be V1, V2 or V3, discharge Q1, Q2 or Q3 is not given any one point. So you have to do the process in this manner. You have to do the process in this process. See the next one. A pipe AB branches into two pipes. A pipe AB and AB, it is branching into two sectors, that is pipe C and pipe D shown in the figure. The pipe has a diameter of 45 centimeter at section A. So section A the diameter of pipe is 45 centimeter. Next, at section B, the diameter is 15. At section C, the diameter is 20. Okay, now determine the distance at A. The velocity at A is 2 meters per second. Also determine the velocity at B and D. The velocity is 4 meters per second. Right? So what you have to find here? We have to find what type of channel. So if the velocity is at 4 meters per second. Right? Now with the figure, you have to write the given data. With this figure, we have to write the given data. So what is the given data? VA is equals to 2 meters per second, right? VC is equals to 4 meters per second. The discharge at AQ is equals to VA into AA. That is equal to pi by 4 into E square PA, right? That is equals to 0.318. Now from the continuity equation, Q is equals to A1 V1, right? Or VA A1 AA is equals to VA BB. Therefore, substitute bringing VB to the one side, the left hand side, and on the right hand side, applying the values, applying the values directly. You are getting the value that is 4.5 meters per second for VB. Now from the geometry of branching pipes, it is follows that Q is equals to AC plus VB. Q is equals to QA is equals to AC plus QD. So QA. So what is the QC here? So AC VC plus AP AD VD. Now substituting QA, already we know QA 0.318. 0.318 is equals to area pi by 4 0.2 square into VC is equal to 4 plus AD into VB. So what is the final answer for the joint at VD velocity? 10.88 meters per second. That is the process how you are doing. So here we are not doing any new thing. Only the continuity equation we are applying, and we are finding the areas for all the branches, and whatever the unknown thing we have to find, for that based upon the similar formulas we are applying those factors, right? Next one, see here, the rectangular pool. Now the rectangular pool is taken. The rectangular pool 10 into 25 meters, length is equal to 10, width is equals to 25, is to be filled in a depth of 3 meters depth. For the filling time of 2 hours, determine the inflow required in meter cube per second. If 6 centimeter hoses are available and the water velocity in each hose is limited to 2.5 meters per second, determine the number of hoses that are required. Determine the number of hoses required. Okay, now see what is the type of design here? The type of design is a swimming pool, which is a of rectangular shape. Now see the given data. The volume of water required, and the swimming in the rectangular pool, the area is volume. Now 10 into 25 into height is equals to 3. So swimming pool depth anta undi ikkada 3 meters undi, antena. Swimming pool depth is 3 meters. Then by volumetric efficiency, the velocity V is equals to 10 into P into D into H. That is equals to 3 times cavity, 750 meter cube. Next, filling time. The filling time is, according to the question, the filling time is 2 hours. That is equals to 2 into 60, 120. 2 into 60 into 60. That is equal to 7,200 minutes. Now, the required income, now the required in the low rate is the flow rate is equals to 750 by 7,200. That is the value. Now discharge through the hose pipe of one hose pipe. Hose pipe discharge anta area into velocity. Area is equals to hose pipe 0.4 into 0.06 square into 2.5. That is the value for the one hose pipe. Next, now number of nozzles required is, this is the number of the hose pipes. No, number of hose pipes is equals to number of hose pipes n is equals to 0.1040 divided by 7.068. That is, total approximation is 15 number of hose pipes are required for the swimming pool in order to remove the sewage water from the pipeline. Better understanding the problems. How many students? Today the attendance is 6. Okay. Next, see the next problem. So in the second unit, majority of the things we were having problems on 80% of problems, 10% of derivation, remaining 10% of theory. Okay, now see the next question. Water flows through the pipe AB. Water is flowing through the pipe AB 1.2 meters at 3 meters per second. So AB దగ్గర మనకి diameter తెలిసింది, area కూడా తెలిసింది at A. Next, and then passes through the pipe BC at 1.5 meter per meter diameter. Now at the point B also, the diameter is known. At C, the pipe branching CD 0.8 meter is also known. So at the point C, the diameter of the pipe is, at the point C, the diameter of the pipe is 0.8 meter and carries one third of the flow in the AB. So carries one third of the flow in the AB, one third of the flow in the AB. The flow velocity in the branch CE is 2.5 meters per second. Find the volume, the rate of the flow of AB, the velocity BC, the velocity CD, and the diameter of CE. So we have to find the definitions. We have to find the definitions individually by checking the analysis. Next, what is the given data? First, write the given data as usual. The diameter of the pipe AB, DAB is equals to 1.2, which is also given. Next, velocity of flow through AB. So that is also given 3 meters per second. Now, diameter of pipe BC, 1.5 meters given. Now, at the point C, the pipe branches. Right, at the point, the branch CD, we are having 0.8 meter pipe and carries one third of the flow of AB. And carries one third of the flow of the AB. Now, the flow velocity of CE, is equals to 2.5 meters per second. Now, let the flow of one pipe, let the flow in the pipe AB is equals to, let the flow in the pipe AB is equals to Q meter cube per second. Flow in the pipe BC is equals to VBC meter cube per second, and in the flow pipe CD is equals to VCD meters per second. Now see the figure. It is shown in this way. So first you draw the figure roughly without any mistakes. Automatically you can score the marks in the problem. Now if you see here you are having a big branched channel. Here the area AB area is 3 meters per second with the diameter is 1.2 meters. Next, the diameter is increased to 1.5 meter. So at a certain point C, it is splitting into 2 dimensions. That is first dimension, that is at the C point C, CD, and the point CE. Now at the CD, the discharge is 0.8 meters. At CE, the discharge Q2 and VCE is equals to 2.5 meters per second. Right now the diameter of the pipe, the diameter of the pipe CE is equals to the diameter of the pipe CE. That this diameter of the pipe CE is equals to diameter CE. Then the flow rate is equals to CD is equals to Q by third, one third in our flow rate. Okay, na? One third, that is equal to Q by 3. Therefore, flow rate through CE is equals to rate in the flow, that is Q minus Q3, that is equals to 2 cube minus 3. That is what is the thing? At the flow rate CE is equals to the total CE is equals to Q minus Q by 3, that is equals to 2Q by 3. Now what is the thing you have to find? The volume of the rate of flow, that is AB. So volume you have to find, AB volume you have to find. AB is equals to Q, that is equals to VAB into area of AB. Now substituting those values, Q is equals to 3 into VAB is equal to pi by 4 DAB square. AB square. Why? Because you are having VA into A, that implies 33 into pi by 4 into DAB square. That implies 3 into pi by 4, 1.2 to the power of 2. That is the value given without the concept, without knowing the concept. Now, if we see substituting this one, we are getting the rate of flow AB is equals to 3.39. Now, applying the continuity equation to the pipe AB and BC, AB key, BC keys. From here to AB to A to B and B to C. So applying continuity equation, VAB into area of pipe AB is equals to VBC into area of pipe BC, area of pipe BC. Now substituting this one based upon the areas, VB into area of pipe AB, 30 into pi by 4 into pi d square by 4, pi d square by square. Now applying this VAB3 into pi by 4 DAB square, VBC into pi by 4 d square by 4. Right? Now substituting those values here, constant. So substituting those values, now we are getting 3 into 1.2 square into 3b into 1.5 square. Substituting here these values, we will get VBC is equals to 1.2 meters per second. So like this, whenever the pipe channel is up instructing, whenever the pipe channels diameters are changing variably. For that also we have to accompany and we have to complete that task. So like this, you have to do the problem for this pipe channels. Understood? What is the next thing you have to find? The next thing you have to find is a flow rate. The next thing you have to find is a flow rate. Next thing is a flow rate. Now CD is equals to Q1 is equals to Q3. Right? CD is equals to Q1, that is equals to Q by 3. Whereas Q, what already we have discussed in this one, Q is equals to 3.393 is equals to 3.393 by 3 times. By 1/3 HRL question low, that's why by 3, that is equals to 1.131 meter cube per second. Now what is the Q1? Q1 is equals to VCD into area of the pipe. That implies this is the thing. Finally, velocity at CD. Velocity at CD is equals to 2.25 meter cube per second. Next flow rate, flow rate through CE. The flow rate is at CE. CE means this point. The flow rate is at CE. The flow rate is at CE. Now the flow rate at CE, Q2 is equals to Q minus Q1. Q minus Q1. That is equal to Q already we know, Q1 we know. That is equals to 2.2. Now the velocity, the discharge Q2 is equals to V into C into area into pipe CE, pi into d power into d to the power of C whole square. Right? Now applying Q2 value is equals to VCE. VCE already we know, 2.5 into pi by 4 DC square. So putting this DC this side, keeping this value this side. So DC is equals to root of 2.23 into the 4 divided by 2.5 into 5. Right? So like this, DCE value we have got 1.07. Therefore, the diameter of pipe C is equals to 1.07. So with this, we have completed this type of changing in the diameter pipe. It may be a branched pipe or it may be a straight line pipe. Okay. So I think better understanding, better understood. Hope you are understanding the problems very easily. Right. Okay. Right. So we'll continue. We'll continue the So we'll continue the problem in the other style. Here, a jet of water from 0.25 meter diameter nozzle. From a nozzle of that 0.25, a high jet of water is coming directly vertically upwards. It is flowing from top to bottom. Right? So this is a nozzle. This is a nozzle here. A high jet of water. A high jet of water. A high jet of water is going directly upwards. Assuming that the jet remains circular. The jet remains circular and neglecting any large loss of energy, that will be diameter of at a point 4.5 meters above the nozzle. Above the nozzle, what's the diameter? Is a 4.5 meter above the nozzle. If the velocity with which the jet leaves of the nozzle is, so the jet leaves the nozzle is 12 meters per second. Okay, now the diameter is 4.5. The rate of velocity is 12 meters per second. Right? Now see, just draw the nozzle. It's a nozzle on. You can draw any as you like. Just draw the nozzle. Right? In this nozzle, what's happening? In this nozzle, a high amount of water jet is forcing onto some surface. Okay, na? Forcing onto the some surface. Right. Now, what's the diameter of the nozzle? The diameter of the nozzle. Why this person is entering many times? You are having any technical issues. Many people are joining and you are exiting. Next, see the data. Given the given data, the diameter of the nozzle D1 is equals to 0.025. Velocity of jet of nozzle is equals to V1, which is already given. V1 is given. Okay. Next, the height at point A. This height at point A is what is the distance from nozzle to the height at point A. The height at point A is 4.5 Newton. 4.5 Newton. Let the velocity of jet of a height. What is the velocity of jet of a height? How much height it is having? It is having 4.5 meters. That is V2. Consider the vertical motion of a jet from the outlet of the nozzle at a point A, neglecting the loss of energy. Initial velocity is equals to initial velocity is equals to u1 v1. Initial velocity is equals to u is equals to v is equals to 1, that is equals to 12 meters per second. So this is a 12 meters per second initial velocity, and jet that leaves the nozzle at 12 meters per second. Now final velocity v is equals to v2. V is equals to v2. Therefore, what is v2 here? 4.5 meters. Therefore, g is equals to 9.81 meter per cube. Yes, that is 9.81. Right. Now, if you see the vertical motion of a jet from the outlet nozzle at a point A, so from here it is going upwards. Initial velocity u is equals to v1 is equals to 12 meters per second. Final velocity is equals to v is equals to v2. That value of g is equals to minus 9.81 and h is equals to 4.5 meter. H is equals to, this is the h is equals to 4.5 meters. Using the equation v square minus u square is equals to 2gh, v square minus u square is equals to 2gh, substituting those values, v2 square minus 12 square is equals to 2 into minus 0.981 into 4.5. Now substituting this one, v square is equals to root of 12 square minus 2 into 9.81 into 45, that's equal to 7.46 value. Therefore, the v value is 7.4 meters per second. Now, applying the continuity equation of the nozzle at A, again the nozzle at A, మనకి రెండు chambers ఉన్నాయి కాబట్టి A1 V1 is equals to A2 V2. Now, substituting A2 values, A2 కనుక కావాల్సింది. Now, all the other values are already we have discussed. A2 is equals to A1 V1 by V2. A1 V1 by V2. So this is a formula. Changing the thing. A1 V1 by V2. Substituting here, you are getting 0.007896. Now, let the D2 is the diameter of jet at point A. Therefore, A2 is equals to so and so. A2 is equals to pi by 2 d square, or the value is D2 is equals to 31.7 mm. 31.7 mm D2 value. So I think so. The next topic is velocity and acceleration. Hope you understood the problems of 1 dimension, 2 dimension, and 3 dimension. Just anyone just raise your hand or just chat me. You have understood the problems or not? Just chat me or raise your hand. Understood or not? users. Yes, sir. Shravani got understood. Remaining, Riyad Sheikh, Snehalata. Snehalata got understood. Right, Manohar, Riyad Sheikh. You came late, but no issues. You can see the video and you can gather the information. Falguna not understood, sir. What is here in that unit 1 row problems are done just now? What is here? Nothing is there in this problem. Okay. So what's the concept here is you are applying the continuity equation as well as the rate of flow. Continuity equation em cheptundi a1 v1 is equals to a2 v2. ఎప్పుడైతే మనకి 3 chambers 4 chambers ఉన్నాయి అనుకో. One example you can see here, Falguna. Here you are having 1 diameter pipe, that is 1.2 diameter pipe. Here you are having 1.5 diameter pipe. Here you are having other diameter pipe. Here you are having other diameter pipe. So ఎన్ని ఉన్నా కూడా the formula will be the same thing. దానికి a1 కి a2 కి లేదంటే a2 కి a3 కి లేదంటే a3 కి a4 లేదంటే a4 కి a1. So like this you have to equate it and you have to do the problem. So a1 చూడండి, everything is given. You have to write the given data. You have to assume the formula or they'll give the formula. సో ఇక్కడ ఏం జరుగుతుంది, ప్రతిదానికి ఏరియా కడుతున్నాం. ఏది తెలియదో అది లాస్ట్కి తీసుకొచ్చి ఉన్నదానికి ఏబి వాట్ ఇస్ ద డిశ్చార్జ్ ఫార్ములా. డిశ్చార్జ్ ఇస్ ఈక్వల్ టు బి బై ఏరియా. అది మనకు తెలిసిందే కదా. నా సబ్స్టిట్యూటింగ్ ఆల్ ద ఏరియాస్, ప్రతి దానిలో మనకి ఏరియా సబ్స్టిట్యూట్ చేసుకుంటూ పోతే ఈక్వేట్ అయినప్పుడు దాంట్లో మనకి ఏదైతే లేదో దాన్ని బయటకు తీసుకొచ్చామంటే ఆటోమేటిక్ ఎందుకంటే సొల్యూషన్. ఐ థింక్ బెటర్ అండర్స్టూడ్ ఫాల్గునా. అర్థమైందా ఫాల్గునా? Here also the same thing. Here the channel is rectangular swimming pool. Okay, right. So ఇది కూడా అంతే the same. Everything data is given. So ఏది లేదో దాన్ని మీరు క్వశ్చన్ మార్క్ పెట్టుకోండి. By seeing the data, just do step by step process. Right? ఇక్కడ ఏం జరుగుతుంది? The water is flowing through the jet with high velocity. Okay na? This is a nozzle. Jet యొక్క nozzle. High velocity and the height 4.5 meters height వెళ్తుంది. So దాన్ని బేస్ చేసుకొని so what will be the other V2s or what will be the other calculation part? You have to just go logically and you have to get the values. Understood? Right. Now the next topic is velocity and acceleration of the fluid. Velocity and acceleration. Now see the velocity. Let V is the resultant velocity at any point in a fluid flow. ఒక ఫ్లూయిడ్ పోతున్నప్పుడు ఒక బాడీ లోంచి ఒక పైప్ లోంచి the resultant velocity at any point in a fluid flow is nothing but V, resultant velocity. Now let U, V, W were the components in x-axis, y-axis and z-axis. So మనకి 3 coordinate system లో కూడా మనకి U, Z, U, V, W like this. So this is a x-axis, this is a y-axis, this is a z-axis. So ఏం చెప్తున్నాడు? In this coordinate system, U, V, W are in the x-axis. So ఇది x-axis అనుకుంటే, ఇది x-axis అనుకుంటే, ఇది y-axis అనుకుంటే, ఇది y-axis అనుకుంటే. This one is z-axis. For x you are having U, for y you are having V, for z you are having Q. Right? So like this, the velocity components are functions of space coordinates and time. Then mathematically the velocity components are given as U is equals to F1 to the bracket of x comma y comma z comma f. Sorry, with respect to time t kabatti x comma y comma z into t. Next, V is equals to F2 of x2 x comma y comma z into t time. W is equals to F3 of x comma y comma z comma t. Therefore, what is the resultant force for the 3 coordinate system x? V is equals to U, V is equals to IJK. V is equals to IJK with the, what are the
components of xy direction, that is u v w. So ui plus vj plus wk, that implies root of u square plus v square plus w square. Now let ax, ay and az are the total acceleration in the xy z directions respectively. Then by the chain of rule of differentiation we have ax అని ఏం చెప్తున్నాం, du by dt, that is equals to du by dx is equal to dx by du, right? Okay, ax is equals to du by dt, du is equals to du to the power of dou u to the power of dx by dou u to the power of dt plus dou u y dy into dt, dou u plus dou z dt plus dou u by dt. So I think the time is also completed. So we'll stop at this position. We'll discuss the class tomorrow. So manaki it is also some type of the formulas. Based on the formulas again you are having the problems within maximum 1 or 2 classes will complete half portion of unit 2. Next manaki fluid dynamics gurinchi manamu discuss chestunnam, right? Now anyone take your attendance screenshot తీసుకోండి. So I took the screenshot. Once the class is completed, this video is uploaded